gives you 1 and 1/2.
How?
If you just plug it in. Because this is 1, 0 is 1 and 1 comma 0 comma 1. 1/2 is 1 comma 0. No, I got those flipped. Don't I? No, then it's E. No, D. I need to throw it out. So wait, I changed my answer.
So it's C.
No, because that
Pi
was
over 3 is 60 degrees.
So
Yes.
D.
Wait, what was your question? Y was multiplying by 2 on the inside?
I got this under.
Okay, alright.
The sign of pi is 0.
The sine of pi is 0, yes.
You don't get
So it's D.
Oh yeah, we just need our bound.
Right.
I had to change my answer. But it's,
You were pretty confident.
I was confident, and then my confidence, of course,
No.
got destroyed.
And you said D. You didn't even have to do it. I said we're going to just find out the bound. There's only one bound like that.
Well,
I mean,
Not
Well-
really.
hold on. So you're saying it's C and you're saying it's D.
It's D.
What's the difference between those two answers?
The bounds are split.
Bounds are flipped, right? This one goes from the square root of 3 over 2 to 0. This one goes from 0 to the square root of 3 over 2. Which one should it be?
It's D.
since pi over 2
Oh,
is
you're
on
saying
top.
Yeah, pi's over 2
Zero.
on
I
top.
have it written down that zero's on top too.
Right.
So I don't know.
So if we're starting at pi over 6, that new bound should be square root of 3 over 2. So it should actually be.
I literally had it written down.
So that, I mean, you got to be careful. The AP test. And this one was from the 2014 test. Okay, this was an interesting question, right? They even tell you how to do the U substitution and just say, what's it going to become? So again, on this one, it's important to know our unit circle. Okay, we had to know that we would end up with sine of pi over 3 is square root of 3 over 2. I guess technically we could have done this problem if we forgot pi over 3. Okay, we could have still done this if we just knew sine of pi, knowing that that upper bound would be 0 and our coefficient out front should be 1/2. We could have still figured out that the answer should be D. Right, yeah, and I mean that's also on the multiple choice. If you can get to that point and recognize my upper bound 0, I should have a coefficient of 1/2. That's the only answer that has that. I mean, use that to your advantage. Save yourself 30 seconds. You don't have to finish the problem.
So let's say that I was confused on where the bound should be, and I wanted to do the rest of the problem. Why is it to the fifth like the power itself?
So our u is sine of 2x. If I look back at the equation, we have sine of 2x raised to the 5th power. So when I do that u substitution, I would say I'm raising this to the 5th power. So this would be u to the 5th times 1/2 du.
And then that happens. Wait, but why is the never mind. When I was looking at it, I was like, the square root of 3 over 2 is like being integrated with the u to the power. But now I understand.
Oh,
It looks
okay.
like it's on top of it. That's why.
Yeah, they didn't type this up too well. But yeah, I mean, this is exactly how it would have appeared on the AP test. So, yeah, I mean, that's the bound. That's not part of the equation.
So, like, would they tell us to like solve it, like, in a question, or like this one? It only asks us to get to the use of substitution.
Right. Yeah, I mean, they could absolutely have asked you to finish this as well. I mean, something like this, if you have to plug in like square root of 3 over 2, that would probably be on the calculator portion if they do ask you to finish this problem. But I like this one. I thought it was interesting because it only asks you to do the use substitution part. Sure. All right, so are we okay with this one?
Yeah, sure.
Yeah.
I don't know if you already answered this one, but on the AP test, for the calculator portion, do you want us writing out, like, what do they want us writing out all of it on the calculator?
For the multiple choice, no. I mean, on any multiple choice question, you need to show 0 work. I mean, probably want to have some scratch work, but they are not going to look at any work on the multiple choice questions. I mean, I have when we've done multiple choice tests, but the actual AP tests, they do not care about your work at all on the multiple choice part. On the free response part, yes, even on the calculator part, they want to see all of your work, all of your setups, and then you can just take what you've written down as your setup, use the calculator to evaluate them. Anything else? All right, so I've heard from multiple people that the homework was a bit of a struggle.
A bit. Underline exclamation points, that's 6 of them. And then italicized, bolded.
All right, so let's start with the multiple choice. How did the multiple choice ones go? And remember, these are calculator questions.
But if the calculator is going to do how the work.
Like, you see the calculator, I got 17 in the area on the 7.
Yeah, that's what I got.
Okay, was your calculator in the right mode?
I don't know.
So this is a trig function, right? What mode should the calculator be in? Rating.
Well, I think my calculator is dead.
Yes, and on all of this stuff, these were all questions in the calculator portion.
Yeah.
So what, for number 3, what would my setup look like? What should my integral look like?
Well, it's going to be 0 to 60.
Right, because we're talking about this first 60-minute interval, so the integral from 0 to 60.
This one's dead as well.
Right, and then just this rate function that they have. Right? We're told this is a rate function. That's key in all of these problems. Okay, this is the rate. So if we integrate the rate, then we will get an amount.
Okay, well, I've had it set up right.
So we could find the antiderivative by hand and then plug in 60 and plug in 0, but we can plug this whole thing into the calculator at once. Right? We can do math 9 and just plug in the integral. Yes.
We're going to have these exact ones.
Would you guys feel more comfortable with these, or if I got the newer ones from, you want these ones?
These
Okay.
ones. I mean,
Okay.
everyone else can. They can put their.
No, these are good.
Oh, nice to see you.
So, I mean, that's why I'm asking. I mean, the newer ones have, a color screen. You can see maybe different equations a little bit better, but if you're more comfortable with these, then we'll have these exact ones for the AP test.
You should round
It's a
the
bit of a problem.
Yes, always to 3 decimal places.
Yay.
But in this problem, it says round to the nearest whole number since it's multiple choice.
What's yours in the different mode?
Yeah, I got 725.
When there's a chair rating, you can figure that out.
I got
If I was in a real life situation, I would.
So yeah, I mean the t over pi is just the same thing as 1 over pi times t, right? So this would actually just be a small u substitution problem if we wanted to do it by hand. I mean that something like this could definitely show up on the non-calculator portion, right? I mean this wasn't. This was on the calculator portion, but I mean I think this would be fair game to show up on the non-calculator portion. That finding that antiderivative isn't so that bad. Finding the definite integral then actually plugging in these values might get kind of ugly.
So, okay, I thought you could only use U substitution if you have something in its derivative. So what is the thing in its derivative?
Well, this is just a linear function, right? 1 over pi times t. So its derivative would be 1 over pi. Technically 6 would be a multiple of 1 over pi, because they're both just numbers. They're both constants. Sure.
I tried to do it.
So we would make our u 1 over pi times t. Now, when we're doing this, all I'm worrying about is this part, the 6 times the cosine of t over pi, right? Because if I'm adding two functions together, I can take their antiderivatives completely separately. So when I'm doing the u substitution, all I'm worried about is the cosine function. So my du then is 1 over pi dt. But I want it to be 6. Well, if I want it to be 6, I would need to multiply both sides by 6 times pi. Right? If I multiply both sides by 6 pi, 1 over pi times 6 pi would just be 6. So I would have 6 pi du equals 6 dt. So then to just do my u substitution for this part, I would say I want the antiderivative of 6 pi times the cosine of u du. Now, since I'm not using u substitution on this part, we would not want to plug in our bounds. We would just want to find the antiderivative of each of those pieces separately and then plug in our actual 0 and 60. We may not do u substitution on the bounds. So this, the antiderivative of cosine is what? Right, so we have negative 6 pi times the sine of u, and my u is 1 over pi dt, or 1 over pi t, so this would be negative 6 pi times the sine of 1 over pi t. Then what's the antiderivative of 12? Yeah, in this case, our variable is t. Yeah, so that would just be t. So to put that together then, my antiderivative of this function would be 12t minus 6 pi times the sine of 1 over pi t. And then to finish out this definite integral, we would want to evaluate that from 0 to 60. It is, right? That's why this was on the calculator portion. But, I mean, something like this could absolutely show up. I mean, we've looked at free response questions where the math got pretty ugly at the end. Okay, so I mean, this is absolutely something that could show up on the non-calculator portion. So I would just plug in my bounds then. So I'd have 12 times 60 minus 6 pi times the sine of 1 over pi times 60 minus 12 times 0 minus 6 pi times the sine of 1 over pi times 0. And again, if this were a free response question, that's my answer. Right? We're not trying to simplify past that. Okay? Once we have something that is all numerical, you do not have to simplify past that.
Why would we need a calculator?
Right. If this
If it
were
was a free response.
if this was a free response, we would just plug this into the calculator and not do any of that. Right? But if this were on the non-calculator portion, we would have to go through this, and then we could stop there. All right, feel okay with that? All right. How about the other multiple choice ones?
Well, since I have a calculator now.
So number 4 was actually really similar. Right? We were given a rate function. Okay, and that's really important. It tells us this is a rate. So how would I solve this problem?
Put it in your calculator and chug away.
Put what in the calculator?
Just the squiggle line, 10, 0.
Yeah, so why are the bounds 0 and 10?
It says years since 1995.
Right. It says T is the number of years since 1995, and we want to estimate the amount of pollution removed between 1995. So there are 0 years from 1995 to 1995, and then 10 years from 1995 to 2005. So I'm integrating from 0 to 10 of this function that they give me, 20e to the negative 0.5t. So that I can just plug into the calculator. Okay, so math 9, plug that in.
I love these calculators.
So what do we get?
40, if it's round up. Because
You say add 9?
Oh,
9.
yeah, math 9.
Oh, I think
So
it's add 9.
no, the
Where
button
we at
sequence on the calculator is math 9 to get to the integral.
And
Where's
then
my
you,
little patient expansion?
but yeah, it's close to 40. It's like 39.
Did you get it? So yeah, it's like 39 point something, something, something. We round to the nearest whole number. We get 40. Alright. You okay with that one? So then the last multiple choice question on the homework was just setting up an integral, right? We didn't even have to solve anything. So it says that this function, r of t, is the rate at which a developing country consumes oil. So how would we set up the integral that gives the total amount of oil consumed by the country during the interval 0 to 10 years? Why is it D and not C? I thought we were supposed to integrate the derivative.
It's D.
Right, so why aren't we integrating the derivative?
Because we would never set it up and all these.
So, I mean, you're right. The answer should be D. But the reason is that this is the derivative function. This is the rate function. Okay? We are told that r of t is the rate. So we want to think about that as the derivative. That's the function that we would integrate. We wouldn't integrate the derivative of the rate. Okay? I think the easiest way to think about that is position, velocity, acceleration. Right? If we want position, we don't integrate acceleration. We would integrate velocity. So in this case, we're given a rate. We would integrate that function to get the total amount. You okay with that one?
You totally had me like scared that I got the
I was just playing devil's advocate.
Okay. Let's do 8.
All right, yeah, so we went through all of 7 yesterday together. So let's talk about 8. This one was from the 2006 test. So, an intersection somewhere in Oregon, cars turn left at this rate. They give us a function that models the rate at which cars turn left, and they even give us the graph of that function. The part A, then, we just want to figure out the total number of cars turning left at the intersection from 0 hours to 18 hours. How would I do that?
Wiggle line.
Yeah, we want the integral of our function that models the number of cars, or the rate at which cars are turning left over this interval.
Again, I love these.
Yeah, so, I mean, this is just plugging stuff into the calculator for part A, right? Making sure we set up our integral. And remember, on the AP test, they want to see this. Okay, so you would need to write this down, but then you can just plug that into your calculator and say equals whatever we get. So what do we get?
1,657.
Well, I got error.
Wait, say it again, 1,658. Okay, so it doesn't explicitly say this in this problem, but we would always want to label our answers. So what would the label be on this? Cars. Yeah, just cars. Because we integrated our rate, so we got the total amount. This was just cars, right? 1,658 cars have turned left over this interval. That's it for part A. Part B then says traffic engineers will consider turn restrictions when L of t, so when the number of cars turning left is greater than 150 per hour. Find all values of t for which this is true, and then also compute the average value of L over this interval. So there's two things we have to do. First, we have to figure out where this happens, okay, where this function is greater than 150. How would I do that? What would the best way to do that be?
Cool. Oh, find the equation of the squiggle lines.
You just estimate. Look above the 150 on the graph.
Yeah, so we want to find where this function is above 150. We don't want to estimate, though. There's an exact way of doing this since we have a calculator. How would I do that?
Graph it.
Graph it and find the intersections, right? We would graph this function and graph y equals 150 and find where they intersect. So go ahead and do that. Find me those points of intersection.
So when we write it out, we'll just say like L of t is greater than or equal to
Well, we would say over the interval, like from this point to this point. But yeah, we could just write that out in a sentence, just like that.
How do I get the graph outline? Like, how do I get
So mode. And then, yeah, if you're trying to figure out what window to use, I mean, they've got a nice window set up here, so we could go 0 to 18 on the x and 0 to 250 on the y, and that would get us a nice picture.
Oh yeah, I can see all my graph.
When did you make it?
So, I mean, the picture they have is just 0 to 18 on the x and 0 to 250 on the y.
And then we use trace, right?
No, we don't use trace.
Please come here. It's definitely
Are you in the right mode? Yes. Let's take a look at. Oh, you made the y scale 250 instead of the y max. I wouldn't say that.
You do.
Well, go for it.
What should I make it?
So what are the
intersection? Why are they?
They were there before.
Oh, I know what This is so I have this so far. So how do I find the internet? I think there's a button.
Okay, are we supposed to go I don't know.
No, because he said we don't have to use trays.
No, find where
Intersect. Calc 5.
Oh, okay, I remember this.
Oh.
I don't. Wait, what does it mean by first curve?
It's the Fermi curve.
What do you mean that?
This
I don't think he has a clue what's going on.
he never does.
I'm just like, yes, or like that.
So 12.48.
I really feel so tempted to know everything. Yeah, how would work last? Good thing.
Woo!
Alright, hold on. Why is my thing not working? Like,
Did I get it?
It's not letting me hit my second curve.
Twelve, 14,
8.
3.
I keep pressing
And then we
enter.
have 16.122.
We want to graph the line on y equals 150 as well. See what those are saying.
So how do I do it?
Go back to y equals.
And do I just put where the pen?
Yeah.
Or as close as possible?
Yeah, it doesn't matter. Well, so it's, you can only do one point at a time. So it's going to ask you on the first curve and second curve.
Where's your fashion? Do I have these 2.3?
Yeah, no, sure.
How do you spell leaning?
Leaning.
All right, so yes. So did we get these points?
I mean, maybe you were close in our guesstimates of the points.
Well, what was it? 12 point something.
14,831.
Since this is an intermediate step, it's not a bad idea to go out to a few more than 3 decimal places. What about the other one?
16.121657.
Okay. So, for the first part of this answer, we would say this L of t is greater than or equal to 150 on the interval 12.428 to 16.122. Right? Then the second part of this question says compute the average value of L over this interval. So how would I compute the average value of L over this interval? Not 18 minus 0. Not 0 minus 18. We're talking about this interval. Yeah, so we would want to do 1 over 16.122 minus 12.428 times the integral between those two values, right? 12.428 to 16.122 of my function. Yep, we just plug all that into the calculator. What do you mean from right? You're going to get better. It's not just something you're good at or you're not good at. You can always improve. And remember, the time breakdown is about 15 minutes per free response question. Okay, so, I mean, all we've really done here is plug some values in. So this isn't going to take an extremely long time. Okay, this is the calculator portion. We've got 15 minutes to do each of these free response questions. So time isn't a huge issue. I think time is more of an issue in the multiple choice part than it is the free response part.
Did you get like 700? I didn't multiply it by, okay.
I got
Something?
I got 199.39.
199.41.
Did you go out to a few numbers? No, it's a 16.
I used the
I used the whole decimal too for the
What's up?
That's what I got
Oh.
first.
All right, so do we get 199.39 or 41? Let me see what the scoring rubric said, if there was a little room for error on that. Let's see. So the actual answer should have been 199.426.
So I was close-ish.
Yeah, so I guess we should have taken these values out to a few more decimal places to get a more exact value. So yeah, on the scoring rubric, they did not leave any room for error. We okay with that one though? I mean, the setup on that. All right. Got 10 minutes left.
We have C on this one. This was the only thing I really did. But not A.
Like on your own before we went over it. Nice.
Not wait. No.
I went out to the full thing and it says 199.16.
I don't know. It's weird. All right. I'd really rather go over the whole next question, but the basic idea for C is we want to figure out if we're talking about a 2-hour interval. We're taking the product of 500. Right? They tell us that every 2-hour time interval, 500 oncoming cars travel straight. So that's just a constant function. So we want to figure out when 500 times the total amount of cars turning left equals 200,000. Okay, well, what that would mean is if I take 200,000 divided by 500, I would get 400, right? So what that's saying is we want to find a 2-hour interval where the total number of cars turning left is 400. There's a couple of ways that we can do that. One is just kind of looking at the graph and saying, well, if I want a 2-hour interval that totals 400 cars, that would mean each hour I would need 200 cars to turn left. Okay, so if I look at the graph and I think, well, look at this interval that's above 200. Well, if I take these points, okay, that looks like that's going to get me at least a 2-hour interval in there. So I could find those values and find this 2-hour interval, 2-hour interval where the total area under the curve would be greater than 400, or we could say that the total number of cars turning left per hour would be greater than 200. Okay, that's the idea for C here. I mean, that is definitely a more complicated thing to think about, right? Remember, your goal is to get 5 or 6 points on every free response question. If you got A and B, you got 5 points, right? So a lot of the time on the free response questions, one part is harder than the others, right? So intentionally to make it more difficult to get that perfect 9 points on every free response. But as long as you get 5 or 6 points on every free response, you will pass the AP test. Okay, so that was the idea for C. Okay, it is a complicated idea, something that is weird to think about, probably not going to be your first thought. Right? But that's the idea. Then number 9, okay, similar situation to some of these problems, except we're given a table now instead of a graph or an equation. So part A says use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30. So we're told that this L of t is the number of people. It is not the rate. This is the number of people in line. So to find the rate at 5:30, which they tell us is at 5.5, t equals 5.5, what would I do?
Slope. Yeah.
Right, we want the slope between the 2 points that are right next to 5.5. Right? So I want the slope between these 2 points. So we would say this, say L prime of 5.5 is about 150 minus 126 over 7 minus 4.
Would I just click off if I can do the
No, I mean, you could write out and say the rate at which the number of people waiting in line at 5:30 is approximately this. What did you do? Just I mean, that would probably be okay, but it's better to write out more than less. Right? So if you're questioning whether you need to label something or explain something, do it. So yeah, we should get 8, and this would be people per hour. Okay, so the line is changing at approximately 8 people per hour. Part B then says, well, take this data and use trapezoids to estimate the average number of people waiting in line during the first 4 hours. So this throws a little twist in there. Okay, they say, find the average number of people. So what we're thinking here, okay, I'm setting up my integral and saying, well, I'm going to have 1 over 4 minus 0 times the integral from 1 to 4 of my function. But they tell us to estimate this with trapezoids, right? The thing that may be tricky that people would forget is to multiply our estimate by 1/4. That's what will give us the average value. Okay, so I would say 1/4 times my trapezoids. So we're going to have 3 trapezoids, right? From 0 to 1, from 1 to 3, and from 3 to 4. So the first trapezoid, my bases are 120 and 156, and my height is 1. So 1 times 120 plus 156 over 2, plus the height of my next one is 2, right? The distance between 1 and 3, times 156 plus 76 over 2, and then the height of my last one is 1. So 1 times 176 plus 126 over 2. $621, including the times 1/4. 155.25 if you multiply it by 1/4. And if we think about the values in the table, that should make sense, right? If we think about, well, what would an average of these values be? 155.25 would make sense as being in between those values, right? So what would my label be on this? 155.25 what? People, right? Average number of people. This is not a rate. This is just the average number of people waiting in line. Okay. You okay with that one? It's a midget, I guess. Is it a small person? Or a baby. I guess that would make more sense.
Midget? So you wouldn't count a midget as a full person?
Would you count a baby as a full person?
In spirit, yes, but not in size. Alright. So we can get through C real quick. What's the fewest number of times that the derivative must equal 0?
3.
How'd you get 3?
I did
Sign chart.
Yeah, you can make a sign chart, right? So, or we can just think, well, I'm going up, I'm going up, I'm going down. I would have to equal 0 somewhere into here, right? Then I'm going down and I go back up. So somewhere in here I would have to hit a slope of 0. And again, I was going up, I go back down. Somewhere in here I have a slope of 0. Okay, the explanation for that is technically mean value theorem.